So you turn the page, you come across a question, and it starts off, these two barrels are similar. And the minute you see that word similar, then it's a magic word as far as the GCSE maths is concerned. Similar means that the two shapes, they're the same shape, but they're different sizes. And what we're going to do is find the scale factor between the two. But what I want you to be clear about, the minute you see that word similar, you're going to write down your table: length, area, volume, because it sets you up no matter how the question plays out. We're going to find the scale factor between either length, area or volume. Well, in this case it's length we've been given. We start off at 1 meters and we go to 2, so the scale factor in this case is times 2, so I'm going to put it in the length column because it's the length we're talking about. Area is two-dimensional. We've got length and width, so whatever we wrote in here we'll do twice here. And volume is three-dimensional, length, height, depth, however you want to view it. So whatever we wrote in for length, we write this here 3 times for the 3 dimensions. And we can see overall then area is going to be multiplied by 4, volume is going to be multiplied by 8. And now you are set up. Because what I might ask in the question is, consequently, I'll keep the numbers simple for this demonstration video, unrealistically simple, just to make sure you've got the idea. So I'll turn around and say that the area, and it could be the area of anything, I'll say the area of the lid, not very realistic, but the area of the lid is 10 meters squared. So what would the area of this lid be? Well, the scale factor associated with area is here, so 4 times. So that lid is going to be 40 meters squared. And I could do it the other way around, of course. I could turn around and tell you that the volume of this barrel, again these are unrealistic numbers, but just for demonstration, the volume of this larger barrel is 160 meters squared. So what's the volume of the smaller barrel? Well, it's volume we're interested in, so it's this row we look at times 8. So this is 8 times smaller, so we'll divide that by 8, and this is going to be 20 meters cubed. So I really can't emphasize enough, the minute you see the word similar, get that table written and populate it. This is a rough and ready video because I just want to get it made. I'm going to do it another way around now. I'm going to tell you that the area of this lid is, let's call it, again completely unrealistic, but 20 meters squared, and the area of this lid, let's say it's 10 meters squared. We see that word similar, we get this table written out, length, area, volume, and the scale factor here is times 9, but it's the scale factor for area, so it's going to be that times 9. Now we've always got to work from length, because whatever we wrote in here, we'd have wrote twice here. So really we're saying what times something times here for here. It was whatever was here, we did times length gave us 9. Well, you might just be able to see that it must have been 3 to give us the times 9 that we've got here. So we've got that times 9. That must have been times 3. And now we've got this times 3, so we can write it out 3 times here. So you've got to be able to do that. If you're given area, in reality, what you're doing is you're finding the square root of whatever the area was to get back to here. And of course, I could do it, another way. That again, you've always got to be careful that they can put, modify these questions slightly to catch people out who have only learned one way. Instead, I could turn around and say, well, okay, this is 270 meters squared, and that's cubed. So now I've given you the volume. It's similar. We write down our table. So the scale factor for volume is times 27. Now remember, this was 3 numbers to get to that. Sorry, 3 multiplications. Something times something times something. It was 27. Now, what you're going to do here, you can use the cube root to get back, and you will discover that it must have been, again, times 3. And we write it down twice here. And sure enough, if we were to write that down 3 times, then we'll get the 27 that's here. So it's all about this. And having got that table populated, now I can ask you any question. So, I'm going to say, right, okay, this is 18 meters high. How high is the smaller barrel? This is a length, so it's length that we look at. This is going to be 3 times smaller, and so that must have been 6 meters. So there's an introduction to similar shapes. Be certain that you can populate this table. If you get the length, it's easy because you just write it there and then you do it twice here and 3 times here. Bit more complicated if it's area. You've got to take the square root to get back to length, and then you can carry on as normal. With your given volume, the cube root to get back to length, and then you carry on as normal, and you're all set up. But this is, a magic word. Now, with similar shapes, any measurement you make for the length, it doesn't matter if I was measuring the width, the height, the circumference, or just, the height of this sort of ring that holds the barrel together. The same measurement on the larger barrel will always be 3 times bigger. It doesn't matter what you choose to measure. If you measure the same thing on the larger barrel, it will always be 3 times bigger. So it works the other way around. If you discover that all the lengths on a shape have been scaled by the same factor, then there must be similar shapes. So it works the other way around. Now, I understand what you've done is the correct thing here. You've drawn out the 2 triangles, which is brilliant, just as I've always advised. So I'm not deceived into trying to contemplate something that's too complicated. So we look at the little one and fill in what we know about the little one, and then we'll fill in the big one. So that's going to be 54, and this is going to be 70, 80. So to prove they are similar, what we should know is that the scale factor between corresponding sides is the same. So we'll check that these 2 sides are the same. Now we only need to do the 2 sides because if these two sides are the same, then because it's a triangle, the 3rd side must be the same. Because of this angle, for instance, and this angle are the same because they're the same corner, and therefore these lengths. So I'm not going to go into that now, but all I'm going to say for the moment is if the 2 sides have the same scale factor, then the whole triangle is a similar shape. So, I've looked at this question, and I went from one to the other and found the scale factor. Can't remember what it is now, and I haven't got my calculator handy. And then I did, so whatever that was, it could have been 2.5. I can't remember. It might have been, but let's just pretend I got 2.5. And of course I do this and I'm expecting 2.5. I'm a bit worried already because of that 0.6, and it isn't. So they aren't the same scale factor. And if you got that far, well done. But they've been very tricky here. These triangles are similar, but they're twisted around. I'm going to sort of take this triangle and sort of turn it upside down. don't know, I just can't think in 2 dimensions. But basically we're going to flip that around. So that's going to be the 80 and that's going to be the 54. And now we'll give this a go. That is a real nasty trick, and I don't think I've seen it crop up before, to be honest, but I've got my phone in front of me, so I'm just going to check. 80 divided by 32, I get a times 2.5, and I'll leave it to you to decide whether these have the same scale factor.